So in this question we're going to look at probability and conditional probability, the law of total probability, and so on. So let's begin. 60% of new drivers in a particular country have had additional driving education. During their first year of driving, new drivers who have not, let's underline that, had additional driving education have a probability of 0.9 of having an accident, while new drivers who have had the additional driving education have a probability of 0.05 of having an accident. So we have two events here, two groups, those who have not had the additional driving education and those who have had it. And we're told that 60% of new drivers have had the additional driving education. That means that 40% have not had it. So we have these conditional probabilities here, 0.9 and 0.5, 0.09 and 0.05. Okay. So calculate the probability that a new driver does not have an accident during their first year of driving. Now, just actually the way it's worded there, does not have an accident during their first year of driving. So that is 0.91 and 0.95 respectively. It's the complements of these two values here, okay? So those are the conditional probabilities of not having an accident given that you are part of one of those two groups, okay? So calculate the probability that a new driver who has had additional driving education, calculate the probability that a new driver has had additional driving education given that he or she had no accidents in that first year. Okay, so the wording is very important here, remember that. So it's best to actually explicitly state all of your events. Okay, so A is that the driver has had an additional education. B is that the driver did not have additional education. Okay, now these are complements of each other. Okay, so I'll just write there complement. Okay, and also it's exhaustive. There's no other possibility allowed for. Okay, you have to be, if you're a new driver, you have to be part of one of those two groups. And if I recall correctly, it's 0.6 for this one and 0.4 for that one, the probability of those two events. Now, C is a different event altogether, has not had an accident in the first year. Okay, so the first question is, calculate the probability that a new driver does not have an accident in their first year of driving. So that's the probability of event C, which is just at the top of the screen there. Okay, so we have a group of new drivers, a new driver, and it could be from group A or it could be from group B. That means that the driver could have had that additional education or not. So this is where we would employ the law of total probability. We partition this event here into these two events here, so we can partition it up. And using the rules of conditional probability, we can express probability of C and A as follows. We can express that using the conditional probability formula of probability of C given A times the probability of A. Okay, so that would be 0.95 times 0.6. Okay, now we're told, probably just remember, we're told this indirectly in the question, where we're told that the probability of them having an accident is 0.5 and also 0.9. So the probability of them not having an accident, which is what we're interested in here, not having an accident, is 0.95 and 0.91, conditional on what group they're in. Okay, so I'm racing ahead there, but I've explained the rationale there. So essentially, the probability of A and C and A is 0.95 times 0.6, and the probability of C and B, calculated using that conditional probability formula and rearranging that, is 0.91 times 0.4. So add them all up together and we should get the probability of C being 0.934. Okay, so the second question is as follows, and it's essentially using the conditional probability formula. Now, the important thing here with these type of questions is to be careful about what you're actually being asked and think about it. And when you're given A given C or C given A, just put a lot of thought into it. Okay? So, calculate the probability that a driver has had additional driving education given that the driver has had no accidents in the first year. Okay? So, we know that the driver, it's sort of explicitly stated here that this is given C, given that there was no accidents. So this sort of stands out, this part here. In fact, in this particular question, it's easier than usual. So calculate the probability that a new driver has had additional driving. That's the probability of A, given that there was no accidents in the first year, given C. Okay. So essentially what we're doing here is this is essentially Bayes' theorem. It's a rearrangement of the conditional probability, essentially. So this is the probability of A given C is the probability of C and A over the probability of C. Okay, and earlier on, using that conditional probability, I've sort of skipped a step there. Probability of C and A can be written as C given A times the probability of A, and we worked that out earlier as 0.95 times 0.6. The probability of C is 0.934. So when we work this out with a calculator, we should get an answer of 0.610. Again, allowing for a bit of rounding error. So we leave it there.